Jai Hind everyone. My name is Aastha Sharma from CSE department at Akgec Engineering College, and my subject is operating system. So today I will talk about the concurrent process, the process concept, the principle of concurrency, the process synchronization, race condition, mutual exclusion, and critical section, as you can see in the concurrent process while running any process and task in the operating system. Next, let's talk about the few aspects about the process concept. So basically, it refers to a program that execute the process into the system. It's a fundamental unit of the work that the operating system manages, and it encompassing about the process code, the data of the current execution of the data sets. It mainly based on to run the programs. It transformed into the process that carries out the process of set of instruction that can be executed while running the any task and execution. So it is a stance of the program that can be executed, but around the system of the work, it can terms we execute the we can execute the terms as kind of the jobs, and many modern processes concepts still expressed in the terms of the jobs. Like while we using the any type of scheduling, the any type of program like CPU scheduling algorithms, we have first come first service, SJF, RR, round robin algorithm, etc. So these are the two terms that can be often used to execute the programs. So let's talk about the few about the terms process. So the process comprises and compiled the program that can be code that can be read in the form of the non-volatile storage when the program is launched. So the data section stores the global and a static variable allocated or initiated prior to the executing main memory, and the heap is used for the dynamic memory allocation that can be managed for the process, or for the process of to create the process, to delete the process, to malloc we uses in C, and the free space memory, etc. Next, we use the stack, which is used for the local variable that can be used to reserved for the local variables that can be presented in the code when they are declared as the space to freed up when the memory can be go up. As you can see in the diagram that this is the process execution, in which we see the stack. In the form of the stack, the process can be executed with the help of the operating system. It can manages all the process in terms of the process control work, like the heap section was there, the data section was there, and the text section, at which the freeing up the space for the local variables. Next, talk about the process states. So process states, it comes when you initiated any type of process executing at the application layer. The process can be executed, that it can be being created, then it can be admitted to the ready queue states. Every process can be requested in terms of being creation, and after that it goes to the ready state. After the ready state, it goes for the running, like authenticating the process. Like in the terms of process proc, we authenticated the process, the location, the memory space was there. Next, after that, if is there any type of interruption or is there any type of authentication required for the process execution, then process goes to the ready state, to compiling, to authenticating the process. After the process complete, then it goes from the running. After the running state, it goes for the input output event, like it can wait for the scheduling the dispatch. After waiting, it can execute the entire complete event completion in the ready queue state, then it goes from the running, and after the running, the process can be terminated. Like it means the process can be existed after compiling all the programs. So in this, the waiting process, the process in terms, it is the waiting for some type of event that occurs in the form of the input output completion. For example, the process may be waiting for the keyboard inputs like disk access request or the interprocess messages was there. Now, the principle of concurrency. It is the type of the operating system that refers the capability of the operating system to handle more than one task at a time, or at a time, by exchanging the efficiency of the particular memory space. So the concurrency is an operating system that ability to execute the multiple types of jobs at the same time in the form of the threads, like in the form of the threads that simultaneously executed the program, improving the resource utilization and the system efficiency. It also allows the several tasks to be progressed at the same time by running the process in terms of the context switching was there, or the single processes was there. So in terms of modern operating system design, it used to handle the multitasking. It also increases the flexibility of of running the program. It also increases the system responsiveness and optimize the performance for user and application. So there are several motivations was there around executing the process in terms of the concurrent execution process. First one is the physical resource sharing. It means the multi-user environment or the hardware resources are limited, so we use physical resource sharing. Next was the logical resource sharing. The shared files in the same piece of the informations was there. Computation speed up, like parallel execution can be executed. Then the modularity in terms of the dividing the some type of function into the several separation, like in the terms of the threads can be divided in terms of process, and every process can execute it on its own, and after the process can compiled in the form of the one thread. Next one is the relationship between the process of operating system. So we have the two types of processes in the concurrent process. Number one is the independent process. Independent process is like it's the state which is not shared with any other processes. The result of the execution, it depends only on the input states, and it results the execution will always be the same for the same input, and it terminates when of the independent process will not terminate at any others, right? Now the cooperating processes was it is a state where the shared along with the other processes. It requires some type of cooperations to execute any types of processes. So the result of the execution depends on the relative execution of sequences, and it cannot be predicted in advance. Like it is type of the non-deterministic nature. The result of the execution will not always be the same for the any type of inputs. The termination of the incorporating process may affect the other processes. Next one is to effective implement on the concurrent. We have some types of principalities was there to execute any type of process in the concurrent processes. Number one is the process isolation. So each process should have its own memory space and resources to prevent the interface between the processes. So this isolation types of we call to maintain the system stability. Like it gives you the flexibility to produce more to do the more multitasking at the same time. Next one we have, second one is synchronization. Like concurrency introduces the possibility of the data races and the conflicts. So it types of mechanism that requires to locks, the semaphores was there, the mutases are used to coordinate access to shared resources to ensure the data consistency, right? Next one is the third principality is deadlock avoidance. It implements, like operating system implements several algorithms. For deadlock avoidance, we use the Banker's algorithm. So in this, operating system implement algorithm to detect and avoid the deadlock situation where process are stuck waiting for the resources indefinitely. So the deadlocks can halt the entire system and it cannot execute the process fully, right? Next one principle is fairness. So the operating system allocate the CPU time fairly among the process to prevent any single type of process from monopolizing the system resources. As you can see in the diagram, the thread, like the process comes in the terms of the thread, it waits for the input output. If the input output can executed at the same time, then it goes from the next execution. It same time it also executed the multiple types of the thread, and it can be allocated, stored in terms of CPU like memory space. Next one is the problem in concurrency. So the concurrency provide you the multiple taskings. It has the ability to provide you the flexibility while using same types of the it gives you the more performance, flexibility, responsiveness. Now the problem, what are the problems we are facing in the concurrency? Number one is race conditions. So they occur when multiple threads or the process accessed shared resources simultaneously without any type of proper synchronization. So this type of without proper synchronization between the threads or the process or the jobs, we call that this type of condition is race condition, right? Next one is the deadlock. So deadlock arises when two or more process or the threads become unable to process as they are mutually waiting for the resources that are currently held by each other. So at this time, the deadlock occurs when two or more processes waiting in the they are waiting in the ready queue state, right? Next one is Priority inversion. Priority inversion occurs when the lower priority task temporarily hold the resources with the higher priority task needs. Next one is the resource starvation. Resource starvation occurs when some processes are unable to execute or to obtain the resource what they are need. So it leads to the poor performance. It has no flexibility while using the program or executing the task in operating system. So these are the four problems in the concurrency. Number one is the race condition, number two is the deadlock, number three is the resource starvation, number four is the priority inversion. Now next is the advantage of the concurrency. It gives you the performance like the flexibility it gives you. Second one is the responsiveness, third one is the scalability, and fourth one is the fault tolerance. What are the limitations of the concurrency? Number one, it increases the complexity. Either it can be in the time complexity or space complexity. Next one is the resource management was there. Next, the issues we are facing for in the principle of concurrency is security, testing and debugging, and the compatibility. Next, talk about the process synchronization. So, process synchronization ensures that the multiple processes or threads can run concurrently without interfering with each other. So it is type of the techniques which is used in the semaphores, monitors, critical sections are used. So these types of techniques, various synchronization processes used. So in a multi-process system, synchronization is necessary to ensure the data consistency and integrity to avoid the risk of deadlock and other synchronization problems. It aims to resolve the problem of race condition, as you can see in the principle of concurrency, and the other synchronization issues in the concurrent system. Let's see the lack of the synchronization. So there is the process 1 with the count equal increment in the count. Next, the process 2, the count in the decrement. So the same time we load the R1, yani task load, and count increments. It is stores in the terms of the variables is stored. So at the same time we increment the value and same time we decrement the value. So load and decrement the value at the same time. So this lack of synchronization in interprocess communication leads to some types of the various inflexibility. The number one is inconsistency. It shares the data at the same time without proper synchronization. Loss of the data was there while incrementing and decrementing the same value at the same time. Loading of the value, loading of the task 1, loading of the task 2, right? So loss of data when multiple processes try to write the same shared resources without coordination. And number third is the deadlock. 2 or more processes get stuck, each waiting for the other to release the resources. Next one is the types of the process synchronization. Number one is the competitive. When 2 or more processes are competed for the accessibility, like the flexibility of the shared resources. So this type of we call the competitive. Lack of the synchronization among competing the process that leads to either inconsistency or the data loss. Next one, second type is cooperative. 2 or more processes get affected by each other, or the execution of the one process affects the other processes. So this lack of synchronization in the cooperating process leads you to the deadlock. The number one competitive leads you the data loss, and the number 2 cooperative leads you to the deadlock. Let's see, there is some type of the Linux code. As you can see, the ps command produces the list of the processes running in the Linux. The grep command is used for the find and count the number of the lines of the output of the ps command. wc, right, the wc command is used for the many words are in the output. So therefore these processes are created which is used to take the input from the pieces, and vcs takes from the grep, right? There are some conditions that requires in the process synchronization. Number one is critical section. So it is a type of the program where the shared resources are accessed and only one process can execute the critical section at a given point of time if there are no shared resources or the no need of synchronization mechanism required. Next one is the race condition. It is a type of the process that is used to trying to access the critical sections, and the final result depends on the order and in which they finish their updates. So it is a type of mechanism mechanism that is used to need the or to ensure the instruction being executed required order only. Next is preemption. Preemption is the operating system which is stopped running the process to give you the CPU for the another processes, and it allow the system to make sure that the input task get the enough CPU time. There next was the problem is producer consumer problem. So producer consumer problem in operating system requires the producer, which means to process, which is able to produce the data or any type of the item. The consumer is, it means that it is able to consume the data that can be produced by the producers, right? And the both producer and the consumer share the common memory buffer space. It can be any type of the variable name, and this buffer space can be certain size in the memory of the system, which is used for the storage, and the process produces the data into the buffer and the consumer consumes the data from the buffer. Next, what are the producer consumer problems? So the producer process should not process any type of the data when the shared buffer is full. So consumer should not consume any type of data when the shared buffer is empty. So when the process can produce, there needs to be the buffer is not full, and the consumer when consume the data, there needs not to be the empty was there. So the access of the shared buffer should be mutually exclusive time. Only one process should be able to access the shared resources and make the changes or the variation into the producer-consumer problem. So to solve the producer-consumer problem, so there are three semaphores variables we used. Number one semaphore is used to indicate the number of the resources available in the particular time, or it is used to achieve the process synchronization. Next is the semaphones. So semaphore, it is used to manage or to access the shared resources. It works on like the signal that allow the multiple process or the threads to coordinate their actions. It counter to keep track of how many resources are available while executing or while scheduling the any type of the task or the jobs, right? Ensuring that no process can use the same resource at the same time, thus preventing conflict and ensuring the orderly the execution of the task or the job. So a semaphore, like as you can see the code, the semaphore like the weight is denotes the semaphore. So the integer variable that can be accessed through the two standard operation was there. Number one operation is the weight, and number two was the signal was there. So the weight operations reduce the value of the semaphore by 1. So it means it can decrease the value by 1, and the signal operation increase its the value by 1. So there is the decrement was there, and there is the increment was there. So this type of variable semaphore variable, it can be accessed by the two type of operation, weight and signal. At the same time, the weight operation is increased, signal operation by decreased by the 1 value. Now the type of the semaphores. So there are two types of semaphores, binary semaphores and the counting semaphore. Binary semaphores, it is kind of the similar to the mutex logs, but not the same thing. It has the two value. Either it can be 0, -0 or the 1. So its value initiated by the 1, and it can be implemented for the solution of the critical section problem with multiple processes. Next one is the counting semaphore. It's the value that can range over the unrestored or unresources domain, and it can be used to control the access of the resources that can hold the multiple type of the instances. Next, the producer consumer problem statement. So we have a buffer size of fixed space. So the produce can produce the item and it can be placed in the buffer. So when the consumer can pick any type of the item and it can consume them, we need to ensure that when the process is placing an item in the buffer, then at the same time the consumer should not consume any type of item. If the producer can produce, the consumer cannot consume any type of the data, right? So in this problem, the buffer is the critical section was there. So to solve this type of problem, we need the two counting of the semaphores. Either it can be full or either it can be empty. If it can be full, so it keeps track on the some items in the buffer at the given space, or either it can be in the empty, so we can keep track on many unoccupied slots was was there or not. So the initialization of the semaphores, we initialized by the 1. So mutex logs is the 1. If it is full, we initially got the slot was empty, so these slots are 0. If the empty is, so all slots are the empty initially, which is the empty n. Next is when the producer produce any type of the item, then the value of the empty, like the waiting period, the value of the empty, right, is reduced by the 1, because one slot will be filled now. So the value of the mutex can be reduced or preventing the consumer to access the buffer. So now the producer can be placed by the item and it can be increases by the 1. So you can see if the producer produce an item, so the weight was the empty, so weight was the mutex. If you want to place any type of the buffer, so we got the signal, yani we incremented by the incrementation was there, so mutex was increment and full value will be incremented, right? So the value of the mutex is also increased by 1, and it, because of the task of the producer, can be completed and the consumer can access the buffer variable. So the solution of the consumer, as the consumer is removing any type of item from the buffer, so therefore the value of the fill and can be reduced by the 1, and the value is the mutex is also reduced, so that the producer cannot access any type of the buffer at the same time. Now the consumer has consumed by the item and it can be increased by the empty value 1, so the value of the mutex is also increased, so that the producer can access the buffer now. Right. Next is mutual exclusion. Mutual exclusion, it is the type of the property, is a type of the another flexibility which is required by the operating systems in the process synchronization, that states that 2 or more processes can exist in the critical section at the given point of time. So the term was first coined by the Dijkstra. So any process, the synchronization or the techniques being used must satisfy the property of the mutual exclusion, without which it would not be possible to get rid of the race condition. So there are some needs required in the mutual exclusion comes in the principle of concurrency. Number 1 is that it handles or interrupts the handlers. Second one is it primitively schedule the process in terms of the threads. Third one is multiple process clusters with shared memory, and it can also be used in the distributed system. And for example, we can see in the mutual exclusion input out, like for example the printer, show any shared data structures was there to execute any type of program. So we have the printer example. Mutual exclusion type of method which is used in concurrent problem to avoid any type of simultaneous use of common resource, like global variable and the pieces of the computer code can be used in the critical section. So there are few conditions was required for the mutual exclusion. Number 1, when using the shared resources, it is important to ensure mutual exclusion between the various processes. There cannot be the 2 processes, so it guaranteed the absentees of the deadlock and the starvation was there. So programming language methods, it provide you the support through the operating system or through the programming languages. Next one is the requirement for the mutual exclusion. At the same time, one process is allowed to enter the critical section. So this type of solution is implemented purely in the software on a machine. So the process remain inside in the critical section or bounded by the time only. So no assumptions can be made about the relative speed of the asynchronous concurrent processes, and the process cannot prevent any other process from entering into the critical section. So the process must be indefinitely postponed from entering the critical section. Next one is the need of the mutual exclusion. So it is the easiest way to visualize the significance of the mutual exclusion to imagine the linked list of the several items with the 4th and the 5th items needed to be removed in the particular system. So without mutual exclusion, multiple threads could simultaneously modify a shared variable. It leads you the incorrected value or unexpected program behavior that leads you the cooperation or the resulting the race condition was there. So as you can see, every item or every jobs can be linked with through the each other. It can be created by the various operations performed in the linked list was there. increment, decrement, and the resultant linked list was there. So the example of the mutual exclusion, number one is the locks. It is a type of the mechanism that applies the restrictions can access to a resource when multiple threads of the executions exist. Recursive lock, it is a type of the mutex devices that can be locked in the several times of the processes or the threads without making a deadlock. So while trying to perform these all type of the locks operation in the mutex, fail or to block when the mutex is locked. So when the recursive mutex or the operations will be success, or if can be the locking the threads is the one of the already holds the lock. Semaphore is a type of the abstract data that designed to control the way of the shared resources. Multiple threads prevent the critical sections problem in concurrent processes. So these types of the condition we call the synchronous primitive. Reader and writer locks are types of that works out the reader or the writer problem. It grants the concurrent accesses to the read and write only processes. Writing the process requires the exclusive access, and it convey the multiple threads can read the data in the parallel forms, and it requires the writing or making the changes in the data. So it is used to manipulate or to access the data structure inside the memory space. The conclusion of the mutex exclusion, the operating system is a frequently used to method for synchronizing the process or the threads that can be accessed the some shared resources, and it also called the mutex. The critical section can be defined as the period for which the threads of the execution can be shared. It is designed to the processes the performing the write operations, and then no other process or the allowed is accessed or alter the any objects. So the mutual exclusion, it is used to prevent the race condition, and it also ensured the middle of the different processes when accessing the shared resources. Peterson algorithm, it is type of algorithm that is used to managing the mutual exclusion and access the critical section at the same time and avoid the race condition. So it shared the two variable to manage the tasking of the multiple process, ensuring the both process follow the order of execution. It also leads you the process synchronization. So its algorithm ensure that one process can enter in the critical section at a given period of time, or while other waits in its own turn. So Peterson algorithm uses the two simple variables. So one of the indicates around the turn of the critical section, another was around it can be processed in the ready queue state. So this manages the scenario the two processes need to share the same type of data interfering with the each others. So as you can see in the algorithm, first one is the do flag, yani in if we are checking in the processor algorithm of the PI process, so it goes to the turn J. At the same time, I and J can be incremented by the value comparison. If the J is can be compared by the flag or turn, the critical section is there, then it can be implemented and execute the any type of the task. And if the another process was while running in the same time, then this process can be wait for the another processes to execute the program. So it is used for the mutual exclusions to ensure two processes do not enter at the same time. That leads to the critical section. So it has the two components, the turn and the flag. Turn, which means the indicates the value to be entered in the critical section, and flag, it comes in the Boolean value that can indicate when the process enter in the critical section. So for example, accessing any type of the shared printer, this is the example of the Peterson algorithm. Only one process can print at the same time and the other two process while waiting in the ready queue state. So reading and writing to a shared file, two process needs to read or to write in the same file, preventing the concurrent process issues. Initial setup is there. Initially we process both the processes in the flag value to the false, and meaning the neither to the critical section. This turns to the IDs of the process. ID can be generated. It can be either in the 0 or the 1, indicating to the process turns to enter. Intention to enter the critical section sets the flag value, signaling to the intent to the enter. Set the turn, it is term of the next turn that the value can be ID, and process the next process of the ID to indicate the critical section. Next, waiting loop, both process can enter in the loop and can be flagged to the other value. And if two process wants to enter, then the flag comparison IDs can be true. Another process can decrement or allows to wait in the processes. So these type of the loops ensure that only one process can enter at the same time for the critical section to preventing the race condition. Critical section, only one process successfully exit the loop if its critical section modify the shared resources. Exiting the critical section, it ensures that the process resets in the flag to the false, and it leads you the signal other process can now have their own turn. Next is Decker's algorithm. It is the mutual exclusion bounded by the waiting in process. There has been the several algorithm implemented, and it firstly implemented in the corrected solutions, and the solution can be used in the terms of the shared memory of the communication. It avoid the conflict of the split of the turn making algorithm. It was one of the first mutual algorithm to be implemented. So as you can see, do entry critical section performed and execute the while other process can be running at the same time in the flags can be used. The type of the value was there. So the first inversion of Decker algorithms as mutual exclusion. It uses variable to control, and it uses the Decker's algorithm to lockstep the and remove the synchronization any updates. So the threads was there. Starting the threads can be implemented. It is critical sections was there. Critical section give you the input output of the threads completed there, and next threads can be executed simultaneously. So this is the next type of the algorithm was there that execute any type of number one, the thread process execute their critical section. Number two, also executed the critical section simultaneously. Dining philosopher was there. Dining philosopher was there. It can be implemented in type of the chopsticks, can be used for the, and the chopsticks can be used in the type of the two picking chopsticks can be picked and can be executed. Sleep barbell was there to process the synchronization, used to illustrate the synchronization issues, the concurrent process, and it can be used for the customer is simulated by the waiting room and simulated by the coordinating one of the chairs in the barber working in this computers customers of the slipping statement. Semaphores was there. While using the semaphores, number one, by checking the condition of the sleep barber, mutex process, then the increment of the value, the next process can be executed. Same as customers can be implemented, setting the states, notifying the barber, and releasing the type of the and executed the states. Thank you.